first installment of our math videos. I'm giving you a portfolio project tomorrow being October 25th. And I'm going to go through a few problems that will be very similar to the problems on your project. Also, throughout this video, I'm going to show you 3 random objects. And if you can tell me what those objects are tomorrow, or anytime this week, then I will know you watched the video for one thing, and I will also give you a Nutri-Grain bar or a Kool-Aid jammer. So, first object. Hope you know what that is. So, the first question I'm giving you is sort of like the question number 6 on page 25. So let's say I'm making, I'm not going to do sweatshirts and t-shirts because I know how many times we've used those examples. Let's say I'm making cupcakes and I am making donuts. I don't know how I would make donuts. I don't even know if that's spelled right. Probably not. I'm not an English teacher, but let's see if that's showing up in the view of the shot. Yeah, that's there. Cupcakes and donuts. So let's say I'm making $6 for every cupcake. Well, we'll say $7. $7 for every cupcake. And I'm making $12 for every donut. So there's some fancy donuts. So I want to determine what my income is. So the question tells me I'm making cupcakes and I'm getting $7 per cupcake. I'm making donuts and I'm making $12 per cupcake. So the first thing the portfolio is going to ask you is, what are the variables in this question? Well, the variables are the things that we're assigning values to. So what are the 2 things that we're assigning values to? Cupcakes and donuts. These are our 2 variables. So we have to assign a letter to each of these variables. So we'll assign X to cupcakes and Y to donuts. So now we need to come up with an equation that we can use to find our income when I sell X number of cupcakes and Y number of donuts. So it's just a general equation that we can use anytime we want to find out what my income is after selling X amount of cupcakes and Y amount of donuts. Well, we know that each cupcake gives us $7. So if we multiply 7 by the amount or number of cupcakes we sell, that's going to give us the income for cupcakes. The amount one cupcake costs times the number of cupcakes that I sell. But our income is also based on the amount of donuts we sell. So how much do we get for one donut? $12. What variable are we using to represent the number of donuts sold? Y. There we go. Found our 2 variables in our problem, and we created our income equation. So next on the portfolio, we're going to have to use, well, also in the problem, you're going to be told, you're going to be given some constraints on these. So for instance, we'll say I want no less than 8 cupcakes sold. So I want to sell no less than 8 cupcakes. Well, I need to write a constraint that represents no less than 8 cupcakes. So no less than 8, well, it can be greater than 8, it can be exactly 8, but it can't be below 8. So what variable do we use to represent cupcakes? X. So the constraint for here would be X can't be less than 8. It has no less than 8. So X is greater than 8, and it can also be equal to 8. X is greater than or equal to 8. That means the same thing as no less than 8. Let me check, make sure this camera's still running. And we're still in business, 5 minutes. Well, I guess it's time to show you another random object. You might not even know what that is. big wooden key. Yes, I'm a goof. So we gotta come up with one more constraint. So I'm gonna get rid of this, because I'm running out of visible room. So let's say our problem also said that we had to sell more than 6 donuts. So that's our second constraint. No more than, or more than 6 donuts. So it can't be 6, because 6 isn't more than 6. It can't be less than 6, because numbers less than 6 are not more than 6. So what's our variable for donuts? Y. Y has to be greater than 6. More than 6. Y is greater than 6. So there's our 2 constraints. And it's always nice to use colors when you're working with constraints. So try and keep it nice and organized. So blue for our donuts and red for our cupcakes. So the next thing you're going to have to do is graph the constraints. Well, both these constraints, neither of them have a slope, right? They both have just intercepts. So this constraint is going to intercept the y-axis at 6. This constraint is going to intercept the x-axis at 8. So let's graph our cupcake constraint. So first I gotta should have done this beforehand. Draw my grid line. Now on your portfolio project, the numbers you're using are going to be such that you can't just assign a value of 1 to each grid line, because if you do, you won't have enough room on your graph to plot your data. I have 12 lines on my y, so I can plot it. You're going to have a number that's so big that you won't be able to plot it on a graph if you only assign a value of 1 to each grid line. So my suggestion to you on your portfolio project is to use each line as 5. So instead of 1, 2, 3, 4, you're going to have 5, 10, 15, 20. That'll make more sense when you see your portfolio project. So let's look at cupcakes. X is greater than or equal to 8. Well, this is our x-axis. Let's find 8. 1, 2, 3, 4, 5, 6, 7, 8. Here is 8 on the x-axis. So I'm going to draw a line up and down. This line represents all places where x is equal to 8. Right here, this coordinate would be 8 on the x, negative 3 on the y. Right here would be 8 on the x, 4 on the y. Any point on this line has an x coordinate of 8. So our constraint says greater than or equal to 8. Well, we use the solid line because the solid line indicates that 8, the value 8, is part of our constraint. Now, greater than or equal to 8. Well, greater than 8 is this way. 9, 10, 11. So we draw arrows going this way. Should go to the very end of our graph. So these arrows represent all the values greater than 8. These markers were coming out darker. Hope you can see it. So now we need to graph our other constraint. Y is greater than 6. Y is greater than 6. Well, we need to find 6 on the y. Here it is. Someone walks in on me now, they're going to think I'm crazy. So there's 6 on our y. Now, this time y is greater than 6. So the value 6 isn't included in our solution, or in this constraint. So we use a dashed line. Oh, the blue is nice and bright. God bless dashed line means that the value 6 is not part of our constraint, but everything greater than 6 is. So our arrows will go up. The arrows representing all the values greater than 6. So now what do you think we're going to do? You hear Mitch telling me. Find the feasible region. Where is the feasible region? Well, the feasible region is the area that has solutions to both our constraints. So where is the only place on this graph that satisfies both constraints? Well, if you look at this little square here, you can see this square contains values of y that are greater than 6, and it also contains values of x that are greater than 8, So our feasible region right here. There's our feasible region. What does the feasible region represent? It's another question on your portfolio project. It represents the area on our graph that contains the solutions to both our constraints. So that'll get you through the first 2 pages of the portfolio. And, okay, third random object. My boot. So you can tell me all 3 random objects sometime next week. I'll give you a Kool-Aid jammer or a Nutri-Ramper.